Hello, welcome back. This is Conversations in Artificial Intelligence. This is Paolo, your host. Today, we're going to talk about augmented intelligence. So what it is? Well, it is one way in which we can utilize artificial intelligence to help human beings, particularly high-level professionals, to do their job in a much more effective way. And with me today, we have the founder of Audit.ai, Daniel Shapiro, tuning in from Ottawa, Canada. Hello, Daniel. How are you today?
Hello. Thank you for having me today. Wonderful.
So, Daniel, first of all, thank you so much for being here. But before we go anywhere, why are you in AI today? What is that happen? I mean, you woke up one day when you were a child and you start to talk about artificial intelligence. What happened? What made you getting here today?
I started off quite a while ago, in 2008 actually, working on an assignment algorithm that figures out what DVDs to send to what people in the mail. It's quite a long time ago, but that operations research problem got me interested in artificial intelligence. And I bounced back from industry to academia to industry. I did some research papers in 2011, then some work on biological neural networks, and then followed by my PhD in deep learning, and then went back to industry to do consulting in deep learning. So it's been kind of a long evolution rather than jumping in, for example, in 2016 or 17 when things got really hot. It was more 10 years before that where things started to click.
What made you really click at a certain point? Was like more of the fact that you found yourself into it, or was more like, no, this is really something I'm interested in?
It was a very slow evolution. So, I mean, chess playing algorithms and Monte Carlo search, you study them in university, but I didn't quite like see it and then immediately jump on it and go, this is what I have to do. I'm passionate about technology, and it's sort of been like a slow evolution towards machine learning is the thing that makes sense to work on. But it wasn't like an all at once realization, love at first sight. I would say that's the big picture of technology, but not the small picture of artificial intelligence. And more generally, people shouldn't want to do AI as the first thing they try. Try something simple, and if it doesn't work, then machine learning.
So one thing I really want to zoom in is augmented intelligence. So for our audience, what it is augmented intelligence?
So augmented intelligence is about helping humans be better at their job rather than replacing humans. In a self-driving car, the idea is to delete the driver and just have passengers. That's not augmented intelligence. What we're talking about in augmented intelligence is kind of like Excel spreadsheets. They make accountants better at being accountants. They don't erase accountants, they just make people more efficient. And that's what augmented artificial intelligence is really about. Taking the part that's easy to automate and automating it, and leaving a human in the driver's seat, but being the best driver possible.
So I think one example of augmented intelligence is the company that you're working on, Audit.ai. So how does it help people doing their job?
So the people that we're helping are auditors, specifically looking at internal audit document review, not the double entry accounting number side, the text side, in many different languages. And what we're doing is realizing if you can detect a loss in the books, in the money, you already lost. What you want to do is avoid that loss, and that's currently a very human-based process. So the way it works is today, humans do things like sampling. They take all the reports, maybe there's 10,000 pages, they take maybe 10% and they review them. That means that 90% didn't get looked at. That's not full coverage, and that's bad. Computers are good at doing boring, very tedious tasks, and this is an example of where we use artificial intelligence to help the auditors to find the key information, the risk statements, the control statements, how they match up to each other, so that they can do their existing process better and faster. So you can't see, for example, in those 10,000 pages, what areas of the company are not discussed. With Audit Map, you can, because it puts things in context of the organization. Internal audit is prone to errors, and computers are less likely to get tired and make a mistake. They can correlate distant information on page 1 and page 4,000. The computer doesn't have a trouble making that relationship, but people that read documents in order do have a lot of trouble. They get tired, the results start to slow down and make mistakes.
So before we go anywhere, let's talk about this auditing process. So why companies audit documents, and what type of companies audit the documents, and how big of a problem is this?
So it's actually a really big problem, billions and billions of dollars kind of big problem. Imagine a large organization, whether it's an aircraft company or a drug company, and reports are prepared by departments, handed to department heads, then handed upstream towards the CFO or towards the CEO. The internal audit function is to go through all these reports and find problems. Unfortunately, in a large organization, 10,000, 100,000 employees, you can't effectively read those reports, especially across years. So let's say you have a 5-year period. To read them all and understand them all through time is very hard. So this is what we're talking about, using AI automation to make that process effective.
What happens if the company is not able to meet the audit? What do they pay for if they fail in the audit?
So there are a few consequences. One is just losses. So they may miss that they're going to experience a loss, and they lose money. Another is a fine. They may get fined if they're in a highly regulated area and they break a rule that they knew about but they didn't fix. Another consequence is just inefficiency. They lose competitiveness. If they can't quickly discover what are the risks, what are the controls controlling it, maybe they have redundant controls, and that costs money. The burden of extra controls that are not actually controlling for a risk is you lose money.
Basically, for our audience, this is a task that it can seem tedious, but it requires a lot of human thinking because you had to make sense of information that is distributed in very long documents. And at the same time, it's very difficult for human beings to execute on this task because the amount of documents is very large, and so they cannot really read all that amount of material. So I would like to go a little bit deeper in the use case and just help our audience to visualize what it is that you do. So we said that one of the problems here is that there is too much to read for human beings, and the computer is able to read all of it very quickly. But another part of it is making sense of these informations, correct? So how does the machine helps the human to make sense of the different pieces of information that are in the document?
So you can imagine that this machine has different colored highlighters, and it goes through tens of thousands, hundreds of thousands of pages and highlights where the risks and where the controls are so that the human auditor can follow their existing process, which is not a simple process. There's an ISO process, there's a COSO process. So auditors have, over the past 100+ years, built a way of working. This artificial intelligence fits within that way of working, within their workflow, to automate the tedious part of picking out what sentences are relevant so that they can build what's called a risk control matrix. So they can match up what risks are addressed by what controls to maybe identify, oh, there is no risk that matches with this control, it's a redundant control. Or similarly, they may find there's a risk and nothing controlling it. Or they may find repeated risks through time. They may find every year this department mentions the same risks, they don't fix it. They're not instituting the controls. And so this is really a framework for thinking about what the company is doing and finding problems. What the AI is doing is helping that process move forward.
If this is true, there is an element of complexity here in understanding the various parts of the test and the various parts of what something means and how things are related to one another. Why is that possible today? Why it's reliable? And why you didn't do this company 5 years ago?
So it actually took 2 years of development ramp up to get where we are, but there have been many recent advances in deep learning for natural language processing. They're well popularized. We've published some work specifically on how you customize word embedding models, like word representation models, to specific domains. That's coming out in February. It's called Sidecar. It's in our GitHub repos. The idea here is that this is sort of the right time for this sort of thing to be addressed. 10 years ago, you would have been using TF-IDF or statistical techniques that just weren't as powerful.
So without going into the details for our audience at this stage, what we're looking here at is the ability to comprehend very large documents that resides into the core algorithms, if you like. It's the evolution of these algorithms that is making it possible. It's not just as in other cases. We have seen in this channel that it was more the convergence of big data and processing power that was responsible for certain innovation. In this case, it's really the algorithm that makes the cut, that makes the difference compared to the past. And one comment I want to make here is that for our audience, as you see, we're moving from, I would say, more tedious and boring type of artificial intelligence, like the computer vision that is counting how many bad guys are getting into a military base, for example, to something that is more complex here, intellectually more complex. We're trying to find meanings inside documents. And you see now that what Daniel's saying is basically the reason why I can make my company and I can make this level of sophistication is because the algorithm, the core technology has evolved. It's not just a supporting layer that has evolved. It's because the core technology has evolved. And so we're going here into more of an artificial intelligence pure play case. But what I want to know is what type of companies really have a particular need for this type of auditing, automation, advanced automation. So can you give us an example? I don't know, is it United Airlines or rather a logistic companies or an agricultural companies?
Let me give you a little bit of background. So we are in the market selling, and we've announced that Six Group is one of our clients. So large entity. Our clients really break down into three areas. There's government, because they have a lot of documents and care about compliance. There's big businesses, so think like Russell 3000, who are mandated by law to do internal audit effectively. And so they're obviously a good customer because lots of data. And finally, the actual audit firms themselves, the Big Four and other large audit entities that do consulting engagements to do audit. So if you are a small company and you don't have it like 10,000 plus employees, huge amounts of documents, you can just read the reports. You don't need AI. You can just do it. The problem emerges at scale. And that's who our good customer is. People who are a chief audit executive, a CFO, that are worried about their job because they're like, what if I miss something? That's a good customer.
Does the customer tend to be more like in the financial industry, in the healthcare industry that are regulated industries? Or you see it more like connected to the size of the company and the complexity of what they do?
So it's actually both. We're finding that highly regulated entities are the ones that are most likely to pay because they're most likely to be fined. But also you have, for example, governments that just have a huge amount of documents and are not able to do this job. They're being tasked with a job that they're not able to do. And so they're looking for a solution, and we're providing a solution. But it's really both. You have to have a large amount of documents, and also you have to care enough about the cost of missing things.
So that's, I think that's interesting. Now, the point is, one of the problems that I think are out there when you go and try to talk to people about you being able to bring this automation is conveying the value of what your automation does, and two is also making them trust that your automation can really make it. So how do you go about selling this service? How do you go about getting the customer really, like making them, really talking to you?
So this brings out a really interesting point in our business model. We're using artificial intelligence to look through the dirty laundry of big companies. They're not okay with a software as a service solution. We have to go on-prem to the stock exchange, to the bank, and install in a very secure environment with no internet and prove to them through a proof of concept that it adds value for them. And then they use it internally, but we don't get to see their data. So a lot of the ruling resistance to get into an organization is you can't see my stuff. And in the end, we don't. So we do an initial engagement to do the install, and then we move to a recurring annual contract to do maintenance and long-term support and to issue them new features to their on-prem deployed solution.
So the on-prem is basically what makes them feeling comfortable that this is something they're gonna be able to use. But in the very beginning, they had to understand that this is something valuable. How do you make them understand that this is something valuable at the very beginning? Like what it is that you communicate in that particular.
So we've been a little bit lucky in that sense that if you just Google internal audit AI, we're the first result on the internet, which is good. So that's a good start. Auditmap.ai gets pulled in from just Google likes us. But separately from that kind of proof point, we do have an online version of the software that we can use to demonstrate with example documents to the client that it works for them. So different clients have different needs. The biggest need tends to be around language. So maybe a bank wants to process French documents, or a different bank wants to process Arabic documents. And so we've designed this multi-language capability, and they want proof that it works for their application, for example, language. And so that's what the initial proof of concept is around, showing them a lot of value in their use case, and then they jump to the recurring subscription.
You're talking about being able to analyze if there are correlations between part of a test that indicate at eye level that there could be a problem, a loss, or could prevent a loss. So it's an eye level concept. This sounds pretty complex tasks. The other thing is that you're indicating that this type of task can be done in different languages, which makes it even more complicated. How dependent is your technology from the language domain?
So this is a problem that we had very early on, and we've actually open sourced the code to address this issue. So we call it Sidecar. It's now been accepted as a peer-reviewed research paper. And what we do, without getting too technical, is we augment the generalist language model with specific extra dimensions to think about the data set of the company or of the industry. So getting a machine learning model to think like a doctor or think like a lawyer, instead of just thinking like, I know English, it goes, all of a sudden, I know all sorts of fintech words to do with that industry and what they mean and being able to contextualize them. So that's called Sidecar. It's on our GitHub repo. And just more generally, we've done a lot of testing. So k-fold cross-validation to make sure that the system works against data it hasn't seen and the split of that data is not important. And also checking on the target language. So for example, the client says, don't just check against your data set, do the validation against my data set. And that helps them a lot to become comfortable to adopt the solution.
So you basically were able to evolve the technology to a point where it's a little bit less dependent on having to retrain and so on. But in a lot of cases we have seen here in conversational artificial intelligence, one big cost of maintaining the technology on the vendor side, so on your side, is this entire thing of training algorithms, labeling data, and so on. If you look at the various cost components of your technology, how much of a relevance does that element has?
It's huge. No data, no AI. It's that simple. So you need to develop a moat that protects you from competitors. And a very big component of that in any artificial intelligence company is data. The algorithms are key, but beyond the algorithms, you need a large, good data set. Now, unfortunately, in our area, it's not something you can Mechanical Turk. It's not like you can put a picture into Mechanical Turk and say, is it a dog or is it a cat? We're talking about very complicated language in different languages. And so there is a real cost of collecting that good data set. Furthermore, inside the tool, there's a relabeling interface. So the end client could decide, I don't agree with this classification, send back to the model. There are multiple models. The risk management frameworks have a model, risk and controls has a model, and for each of them, the user can say, thank you, AI, but I disagree about this sentence, label it this way instead.
So I wonder if you can tell us a little bit more about the technology. What is the secret source that is inside this product to basically, let's repeat it once more, it helps internal auditors to read very long documents, spot information that can be analyzed by human beings and can determine basically whether or not there is a risk to make losses, something that goes wrong, or if everything is okay right now.
Yeah, so let's dive a little bit deeper into the technology to give you a sense of what's under the hood. We're using supervised learning to classify statements in the context of their paragraphs. That's one. So you have a sentence and then you put a label. In named entity recognition, we're using IOB format to extract entities like Canada, bank, children, insurance. So these are each entities that have relationships with each other. And so you have like an entity relationship map. So besides for the supervised learning part, which is like learning to apply a label to a thing like a document or a sentence, there's also unsupervised learning, which I discussed earlier. And the concept there is that you take in a large set of documents to learn word representations that are good, that are predictive. So there's a supervised and an unsupervised component to understanding the documents, and that allows us to plug into the existing flow of auditors. So rather than saying, oh, we have magic AI, we're going to make up a new process for how to do audit, instead, we took subject matter experts from audit and said, show us your process flow. And we align things along that process flow. So, for example, there's these what's called ERM, Enterprise Risk Management Frameworks, and we use our labeling to apply to that framework, to do like an auditor does. So rather than replacing the auditor, we're helping them to apply those labels to build their risk and control matrix. And in doing so, they can find stuff they wouldn't find, for example, outliers or repeated risks or repeated controls, where you say, like we talked about earlier, every year the same thing is happening. It's hard to notice as a human, but computers are good at picking up on repeated the same thing in the same department. You also have a way of doing a gap analysis of saying, wow, the R&D department doesn't say any risk and controls. They give in a big report every year, but it doesn't have anything in it. It's just empty. In other words, filler. And that allows the auditors to say, wait, what if there really is a problem here? So yeah, there are quite a few different machine learning technologies taped together to do that process that we just discussed.
So when a customer comes to you, is there a phase where you need to customize either the intelligence or the way that the intelligence it gets integrated in their processes?
Yep, so the short answer is yes. Every company has a different audit universe. This is an entity defined in the audit space, and the audit universe is the segments of your company. It's like looks like an org chart, and it breaks down the pieces of the company and what reports to what. So the documents have to be mapped into that tree that's different for each company. Maybe in a large organization, each major unit has its own accounts receivable and accounts payable. Or maybe in another organization, it's all centralized, one central AR and AP. So we don't know that. We need to work with the customer to define that audit universe. It's like a JSON object that defines their company so that we can direct the AI to put things in the right buckets and to see the right information over time. So that's an example of a customization that's part of the install process.
What are the things that people need to understand the product quickly and then leverage the product and also help you to improve it so that the intelligence inside the product can grow over time and become more helpful for the person?
So the user experience design has evolved a lot since our initial prototype. I would encourage developers to think about the process flow rather than like the design of the screens. And as long as you're following the flow that users already accept, they're going to put up less resistance to the new system. As soon as you go like, I'm going to create a brand new user flow because it fits my algorithm better, users are going to be a little bit confused because they've trained from university until deep into adulthood to do things a certain way. The less you mess with that a certain way, like imagine if you said, I'm going to make a new car, but the steering wheel's on the roof instead of in front of the user. They're going to be super annoyed. So what you want to do in the interface design is try and be as simple and also as non-disruptive as possible, but still add in as much like fancy capabilities. So there's a trade-off there. Like I, as a machine learning developer, would love to put in all sorts of bells and whistles that the subject matter experts have said back to me, I don't get it. It's like a very fancy picture, bright colors, but I don't get it. So for example, a correlation map. I think correlation maps are a very interesting tool and useful, but auditors look at this bright blob and they're like, okay. Or the common thing in word embedding is to graph in 3D the words and their relationships to each other. But auditors don't think like that. They're like, I mean, pretty, but like, how does this help me? So yeah, the user interface design has to demonstrate utility, not just fanciness.
How you get information from the users that you can use to improve your algorithms? Does your solution need to get better in time? And if the answer is yes, how do you incentivize users to give you that information?
That's what the system does. It has a relabeling interface so that if the system made a mistake during an engagement, for example, let's say it said this statement is a certain kind of risk, but it was the wrong kind of risk, the auditor, as part of the task they're trying to do, will be doing the relabeling kind of for free. They're relabeling it by saying like, no, it's this, and then grabbing it and putting it into their workflow. Now, the system learns from that, but we do the retraining like on a quarterly basis, not live. That would be way too dangerous. So the reason is we want to go through a quality assurance flow to make sure that the model is not messing up, and also to make sure that it retrains on lots of data and not just on like one new sample. But yes, it does get better over time by taking into context more labeling at the client site about their specific business, but also we deploy new versions of the model from our labeling that we do so that they're continuously getting newer versions of the product.
So you're saying basically that you retrain these algorithms every quarter. What are the requirements for this retraining to be effective?
So it's actually a very quantitative process. We look at, for example, in the risk and control model, where we're saying like, is the sentence a risk or a control or other? What we do is we measure the F1 score, which is like the harmonic mean of the recall and the precision across data that the system has not seen. That's a very, very strong validation that the system is working because it's doing inference on data it never saw. Now, what we need to remember is that the incumbent technology is humans, unassisted, and they make lots of mistakes. So they do sampling. They literally like take a big chunk of the reports and then don't read them at all. The important thing is that the process is continuous improvement. I'll never be satisfied and say like, yeah, we don't need more data. We always need more data, but there is diminishing returns. So what we've observed is that when you're at about 85% accuracy on whatever model, getting each percent more takes more and more and more effort.
What use cases you see that the technology today cannot solve, and what do you expect is going to be solved in the next 10 years?
What we found is that chatbots for interrogating the data that customers put into AuditMap is not very good. People either have a very bad experience right away where they try and ask it to do something complicated and then it fails, or they assume that it's too simple and they're too annoyed to use it and they want to use the user interface. So user acceptance of chatbots across all of the AI industry has not been very good. It's being deployed because it saves money compared to using humans. But in a high-end product like AuditMap, you don't want to include technology that annoys people. And so chatbots are not a solved problem just yet.
How would the chatbot help the auditor? It basically would be an assistant, something that helps them, like they can ask the questions and so on. You cannot do that.
No, the reason is that this is a very context-rich area, and chatbots work on entities and intents. And the intents that auditors want to use have multiple entities and multiple contexts. And it's kind of too much for the user, not for the AI, but for the user to comprehend. And so when you call into a voice system for a bank, let's say, you have a very, very specific use case in mind. But when you're talking to a set of audit documents, you don't have a very tight use case. And that like broad, it's called a question answering system, is not very performant right now. There's a lot of research models if you look up question answering systems. Stanford has some wonderful models, but the way that these models understand language is currently limited to predefined use cases. That's why Alexa or Google Voice will tell you, I can't do that yet.
So what we will see, you think, in the next 5 years that will solve this problem? Do you expect to put the chatbots in your products in the next 5 years?
I don't know. I honestly don't. And people who are like very definitive about what's going to happen in the next 5 years probably don't know what they're talking about. Transformers are very interesting. There's been some new developments in the technology and it's continuously improving, but it's not ready yet for us to do an integration. It's not strong enough. It may not be, or it might be. I don't know yet. Let's see what the future holds.
what it is that doesn't work today. Is the algorithm only, or it's the computational power as well?
I think it's the algorithms themselves. They don't contain enough context. There's something called a vanishing gradient problem, where if you have like a long sequence, it's difficult to remember what happened before. Unfortunately, people think that this is solved. It is not solved. There are these endemic issues that we've known about since the 1980s that haven't gone away. We've just managed to find some use cases where we can fix it, and which is amazing. But those use cases are narrow, and broad use cases like general understanding, like HAL from the movie Space 2000, that kind of AI is not a thing. That's not in existence, and I don't know when it's coming. But if it does, we'll use it.
What is an area where you don't work in AI, where you expect great things coming up, or where you would like to see great things coming up?
Sure. So, I have an interest in biological neural networks, and I think it's going to be quite interesting over the next few years to see translations of research from the artificial neural network space into the biological neural network space. We're getting things like CRISPR that are very good at gene editing at the low level stuff. At what point will we start to wire up biological neural networks to do interesting things? To do, for example, prosthetics that are alive. These are very important needs that are not theoretical. People really do need new limbs that work better. It's not there yet, but I'm excited to see what will happen in that area, given that we're starting to understand so much about how neural networks operate, or at least we're starting to realize how much we don't know.
So this was, I think, a great conversation for our audience today. If you have questions about this, comment below where you see this video on YouTube, Facebook, or LinkedIn. Daniel, thank you so much for being here today. Good luck with auditmap.ai. I would say the first augmented intelligence startup that is trying to help the auditors in billion-dollar companies in a multi-billion-dollar market.
Thank you for having me.